All right. Using health records of every student at high school, school nurse created a scatter plot relating y equals height in centimeters to age in years. So very important for you to recognize what x represents and what y represents,
Okay.
because they're either going to give you an x to find y or a y to find x. Okay.
Right.
So in this case, they tell you, according to the population regression line, what is the average height of a 15-year-old student? Are they giving you x or are they giving you y here?
They're giving us X.
So you're going to put that number into the equation. 105 plus 4.2 times 15.
Okay. The standard deviation. Okay. And then we just plug that into the calculator.
Yes. Okay.
I got 168.
Okay. We'll go with that. That's fine.
Oh,
All right. Now the next thing here, this is where it gets a little more interesting. The next question is, it says, what percent of 15-year-old students at the school are taller than 180 centimeters? So we're looking for the probability that x is greater than 180 in this case.
okay.
Does that kind of resonate with you?
Yeah, that does
Okay.
sound familiar.
We kind of assume that this is mu, but let's back up a second. We need to calculate what 15 is, and you did that for us. So what we're doing is normalizing here. Is my best interpretation of this. We're going to use a normal distribution, normal CDF here, because they're giving you sigma. Sigma is the big indicator that it's a normal distribution. So whenever you see sigma, you can think that. So a couple options here are to go to normal CDF on your calculator, or you can calculate the z-score by hand, or maybe another option that I haven't thought about yet. What do you think you would normally do here if it was
You
normal distribution?
probably plug it into the calculator.
Normal CDF?
Yeah.
Okay, so why don't you go to normal CDF and tell me what you see. I think it's going to have some options for mu, sigma, x, maybe n.
Okay.
Not sure. I think it's an upper and a lower situation as well.
Gotcha. Yeah. What do we plug in the upper and lower usually?
So let's go here. We just calculated that 168 is like what we think the average 15-year-old should be. So we'll go 168 right in the middle. And then this 180 is what we're interested in. We're actually interested in 180 and then all the people taller than 180.
Right.
Okay, so when it's 180, 10 to the 99. So this first one is your lower. If you don't know your upper, that's when it's 10 to the 99. Your mu is 168 and 7 is your sigma.
Okay. I got 0.043.
That sounds right, about right.
All right. Okay.
The reason I know that is 2 standard deviations away is where we're at kind of roughly, and that's about, it's going to be in this area. Usually you go out to 4 decimal places on areas as well.
It would be 0.0432 then.
Okay. What's your comfort level with this normal CDF? Because we just covered the greater than case.
Okay. I'm pretty good. I just kind of need, like refreshing my memory kind of, because this is just like a little bit of review and like plugging it into,
yes,
more advanced stuff. So it's just kind of a little bit of review for me, but I do remember the plugging into norm CDF, just remembering what to put into like, the lower and the upper and whatnot.
Yeah, it really comes down to, there's only 3 pictures that you need. So let me just quickly do those for you here. We've already done one of them. So if you want to go greater than some number, I'll just say 180 again. That's when, and you already have this one, it's 180, 10 to the 99. If you wanted to go the other direction, less than, so probably that x is less than, so whenever it's a less than, it's negative 10 to the 99 to 180. So notice the two just switch positions.
I see.
And then if it's a between situation, like let's say it's 120 to 180, then you have the numbers for the upper and the lower. It's 120 to 180. And you still need your mu and your standard deviation, but these are the only three scenarios you'll see.
Gotcha. Okay. Huh. I was always a little bit confused by that, but thank you.
Do you feel like it's clear now, or do you want us to do some more examples?
That it's definitely clearer to me now.
Okay. All right, part C says if the nurse used a random sample of 50 students from the school to calculate the regression line instead of using all the students, would the slope of the sample regression line be exactly 4.2? Let me ask it differently. Could it be exactly 4.2 is kind of the way I guess I would ask you part A, and part B is, well, let's just see how you answer that.
Let's see. The nurse used a random sample of 50 students from the school.
And if you're not sure an answer, I'll pose a different scenario here to try to explain this.
The slope of these regressions might be exactly 4.2. Probably wouldn't be, right?
Most of the time it will not be. Okay.
It will not be.
But there's a chance, like there's a chance that you could, choose the samples that actually perfectly works out to 4.2. Okay. It's pretty unlikely though. And that's kind of a core idea of this course. It's kind of like playing the lottery. Like, could you win? Yeah. But will you win? Probably not. It's very hard to do this. Because it's a sample of 50, unless you sample everyone in the population, that's how you will get the 4.2, to sample every single person in the population. Then you would for sure get it.
Okay. Okay. Gotcha. Okay.
All right. What's the next question to look at?
I think it's 66.
66. So we're going in order here. All right.
Yeah, pretty much it's from 65 to 68 for now.
Okay. All right, using the daily high and low temperature readings at the airport for an entire year, meteorologists made a scatter plot relating Y as high temperature to X low temperature. Okay, I'm not sure why you do that, but go ahead. Okay. After verifying that the conditions for the regression model were met, the meteorologist calculated the equation of the population regression line to be mu y 16.6 plus 1.02x with a sigma equals 6.64 f. This is a lot like the previous one. According to the population regression line, what is the average high temperature in days when the low temperature is 40? They're telling you that that is X.
Right. So you just plug it into the equation.
Yes.
Okay. And then just plug it into the calculator. All right, and I got about 57.4.
Okay.
So what is the average high temperature on days when the temperature? Okay. Huh, interesting. All right, we can move on to B. Thank you.
All right.
Oh, man,
About what percent of days with a low temperature of 40 degrees have a high temperature greater than 70? So this is the probability that X is greater than 70. So if we're looking at the curve here again, it's 70 to infinity basically. So this This is a normal CDF situation. 70, 10 to the 99. And then we need our mu and sigma here. So your mu comes from what you just calculated, 57.4. And your sigma is the given value of 6.64.
Got an interesting high number. I don't know if I plugged it in right, but I got 6.23.
Is it times 10 to the minus something?
Yeah,
What's the minus?
78.
Like this?
Or it's got the E in this minus 78. So
That's fine. So that's effectively 0.
okay, that's practically 0.
Which is a little bothersome here, but it is kind of a map, similar to the previous one here.
Right, right.
57.4. Your standard deviation though is 12. Huh. I'm going to try it as well because I don't like that number you gave me. I guess
Yeah.
to me it should have been closer to what we got in the last problem,
Right.
but I really don't know. So let me do that calculation here if I can figure out how to do that quickly. Sometimes good to do the calculation again, second
Right.
time around. See if there's any differences. All right, calculators, normal
There
calculator.
we go. Yeah. No, something was off there.
All right, I'm almost caught up to you. Greater than or equal to 70. All right, I got 0.0289.
Yeah, that's what I got too.
Okay.
Yeah, I accidentally plugged in the previous answer for 180 for the lower
All right. Yeah, that'll do it.
instead of it. Yeah, for sure. I was like, that is way off.
So C is the exact same question we got for 65. It's the same answer. They're asking you, will the regression line of the sample actually be 1.02? Like the only way you get exactly the slope is if you sample everything in the population, or you're just lucky, or small chance.
And could you write that in an AP exam, or would you have to be like a little more descriptive of it?
Oh, on an AP exam, I would no. That was more for you. Sorry.
I see.
No, you would say it would never. It's or you would use words like it's unlikely to be exactly 1.02 unless you sample everything in the population. This is not an AP free response question.
Right, right.
So they would.
Yeah, no, it's
have to
definitely a
ask it.
bit of an odd one. Oops. Okay. All right, we can move on to 67 now.
Okay, oil and residuals on the pipeline. Figure below shows a residual plot. Did you guys look at any residual plots for the least squares regression based on?
Yes, yes, we have.
Okay, so one of the things you're looking for the residuals is a linear pattern,
Right,
and this doesn't have it.
right. It's
So one of your book will have something on there like what we really were hoping is something like this. like the dots to be along a line like that. These are not, so that's one of the conditions that are not met. And that's sufficient to say that it's not met. So the residuals need to form a line, basically.
Right.
They should fit on a line.
They could kind of be all over the place too, because this one kind of shows somewhat of a pattern.
Yeah, they're actually getting worse. You know, they're spreading out. Excuse me. And there's probably a term for this. There's other things that you don't care about in this course, like autocorrelation and some other things that you will see if you take this class at a university level, but you just need to know that the residuals need to form a line.
Okay. And here they do not. Oh.
Okay. That's why I'm kind of, curious, like, did they not talk about this in class, or?
Yeah, no, they do mention
Okay.
it a little bit.
Okay. So like 68 is really interesting, and because it actually shows a pattern, kind of like you're referring to. The pattern here is a curve. Like you can kind of see like a U shape.
Right, like a smiley face kind of.
Yeah, this is also bad. It should be a straight line. the like the way you might see this on the AP would be in a multiple choice scenario, which is they give you 4 residual plots, and the one you're looking for is in a straight line. Would be okay.
Right. Okay, interesting. And then okay, I guess we can move on to 69 now.
69. Is this is asking if they're met? Check whether the conditions.
Oh yeah.
This one is somewhat better. The frequency residual plot's a little bit more useful. Let me snip this in here. If you recall from much earlier in the course, the frequency plot, you could try to derive the shape of the distribution. And this one, it depends. Like if you kind of believe that that's okay, or if you're like, well, I don't see that. I think it's more like almost like an exponential distribution. I don't really, I mean, this one over here is pretty bothersome, this peak, but I guess you could make the case that it's normally distributed, the residuals. Okay. But when you look at the scatter plot of the residuals, does it form a line? Not great. Okay, but I think you'll find there's also an issue, or the other thing you're looking for. The question is, well, is this okay? And I have a hard time saying that that's okay, but let's just say it is for a moment. You're also looking for the magnitude of your residuals. They're not supposed to be like greater than, like, I'll say 2 or 3. I can't remember what books say, or less than -2, -3. You don't want them to be so far away is the issue with the residual, because the residual is actually kind of like it's your offset from the true value. So there's some guidance there on that. Do you have anything from your book to maybe help guide us?
Let me take a look.
I tend to want to say that this one is okay.
Gotcha. Let me see. Wait, this was 69. Oops, past it. Linear. There is no leftover curved pattern in the residual plot, indicating that a linear model is appropriate. Independent, knowing the BAC for one subject should not help us predict the BAC for another subject. Normal, the histogram of the residual shows no strong skewness or outliers. Equal SD, the residual plot shows a similar amount of scatter about the residual equals 0 line for each X equals number of beers. Random, the students were randomly assigned a certain number of cans of beer to drink. Huh.
Does any questions or anything like they're stand out to you or not?
Yeah, it's just kind of checking the conditions of it.
You're looking, the easiest thing to find are the curved shapes of the residual plots or outliers, things that are really far away, influential points, which are different than outliers, but this one looks good. I don't
Okay.
see any issues with this.
Right. Okay. Awesome. Well, that's all the ones I got for today, but if you're okay with ending class a little bit early, because there's another one, but I think it'll probably take a little more time than
Yeah, real
you're
quick here.
available.
Let me just stop the recording here.